Forget everything you've been told about Mars being humanity's next home, because the truth is far darker than the postcard version we've been sold for decades. Strip away the concept art of glass domes and red sunsets. Strip away the dream of cities rising out of the dust, and what's left is a planet actively trying to kill anything that sets foot on it. A world that once had rivers, lakes, maybe even oceans, and somehow, over billions of years, transformed into one of the most savage environments in the entire solar system. And that transformation is exactly what makes Mars so unsettling. Because out of every planet we've ever studied, it's the one that looks the most like home. It has polar ice caps, it has seasons, it has clouds, mountains, valleys, deserts, the unmistakable fingerprints of ancient rivers carved into its surface. At a glance, it looks familiar, almost welcoming. That feeling is a lie, because underneath that deceptively Earth-like face sits a frozen, irradiated, nearly airless world, a planet that humiliates machines, breaks missions, and would kill an unprotected human being in minutes. So what actually happened here? What turned a planet that may once have been habitable into one of the most hostile places we know of? To answer that, we have to go down to the surface itself, into the conditions astronauts would actually face if they ever tried to live there. And that's where you start to realize just how brutally unprepared most people are for what Mars really is. Start with the air, because there basically isn't any. On Earth, we live wrapped in a thick blanket of gas that shields us and gives us every breath we take for granted. On Mars, that blanket is almost gone. Surface atmospheric pressure on Mars is less than 1% of what we experience at sea level on Earth, which means standing unprotected on the Martian surface would feel something like being dropped at an altitude far higher than the summit of Mount Everest, except worse, because there is no slow acclimatization, no gradual adjustment. Without a fully pressurized suit, a human being would lose consciousness almost immediately. Oxygen is virtually non-existent, and the near vacuum pressure would begin affecting your blood directly. And the lack of breathable air is only the opening act. Average surface temperature on Mars hovers around minus 60 degrees Celsius. At night, in certain regions, that figure can plunge to minus 120 degrees, cold enough to freeze unprotected equipment, almost instantly. During the day, areas near the equator can briefly climb to surprisingly tolerable temperatures. But that sense of comfort evaporates the second the sun dips below the horizon, because Mars's atmosphere is far too thin to trap any meaningful heat. The warmth simply escapes straight back into space every single day, like clockwork. And then there's water, maybe the most genuinely strange part of the whole picture. We know there's an enormous amount of ice scattered across the planet. Ice at the poles, ice buried beneath the surface, ice mixed directly into the soil itself. But finding liquid water on Mars is, for all practical purposes, impossible. Atmospheric pressure is so low that water simply cannot remain stable as a liquid for any meaningful length of time. Instead of pooling into rivers or lakes, it either freezes solid or flashes straight into vapor. It's a jarring contradiction, because everywhere you look, the evidence says Mars was once an entirely different world, one with rivers, lakes, maybe oceans. Today, that world is gone, replaced by a place where breathing is impossible, where cold dominates every inch of the landscape, and where even water itself struggles to simply exist. But none of that, not the cold, not the lack of air, not the vanishing water, is actually the biggest threat waiting for future explorers. Because hovering above the Martian surface, completely invisible, is an enemy that bombards the entire planet every single day, and could turn a routine mission into a death sentence. Radiation? Unlike Earth, Mars has no strong global magnetic field protecting its surface. Billions of years ago, it almost certainly had one, a magnetic shield not unlike our own, but at some point that internal mechanism weakened and eventually shut down completely. And when it did, Mars was left exposed. With no shield left to deflect them, particles streaming from the sun began striking the planet's atmosphere directly, and over billions of years, solar wind slowly stripped away most of the gas that once surrounded Mars, gradually turning what may have been a warmer, wetter world into the frozen desert we see today. That process never stopped. Right now, in this exact moment, Mars is still being bombarded by energetic solar particles and by cosmic rays, tearing in from interstellar space, invisible to the eye, but carrying enough energy to punch through biological tissue, damage living cells, and corrupt the fundamental molecules that life depends on. On Earth, we almost never think about this, because our atmosphere and magnetic field act as a kind of natural armor, intercepting the overwhelming majority of that radiation before it ever reaches the ground. On Mars, that armor is essentially gone. For future astronauts, this is one of the single greatest obstacles standing between us and any serious long-term presence there. A real mission wouldn't just mean months traveling through deep space exposure. It would mean years living afterward in an environment that never stops irradiating you. The risk of illness climbs sharply. Electronics degrade faster. Even prolonged exposures, effects on the human brain become a real concern. This is exactly why so many proposed Martian-based designs involve habitats buried underground or shielded beneath thick layers of compacted regolith. On Mars, simply living on the surface might not be survivable at all. You may need to live hidden from it entirely, which leads to an unsettling realization. Mars isn't just cold, and it isn't just airless. It's a planet that lost its natural defenses, a world left exposed to the raw violence of space for billions of consecutive years. And the consequences of that long, slow exposure are written across its surface in scars too massive to ignore, evidence of a planet that was once far more violent than most people ever imagined. From orbit, Mars can look almost peaceful, a vast reddish desert dotted with craters, plains, and mountains. Get closer, and that illusion shatters immediately because the surface is marked by some of the largest geological structures found anywhere in the solar system. The most staggering of them all is Olympus Mons, and calling it simply a volcano almost undersells what it actually is, because it is the largest volcano in the entire solar system. Its base spans roughly 600 kilometers across, an area comparable to an entire country. Once, so far, no definitive proof has ever been found, but discovery after discovery keeps that possibility stubborn. And there's another mystery layered on top of all this. Periodically, instruments detect small traces of methane in the Martian atmosphere. On Earth, a significant portion of that gas comes directly from biological processes. There are plausible once, so far, no definitive proof has ever been found, but discovery after discovery keeps that possibility stubbornly alive. The Perseverance rover, for instance, is currently exploring Jezero Crater, a region that scientists believe held an ancient lake billions of years ago. The rock samples collected there preserve a record of an environment that may have remained habitable for a remarkably long stretch of Martian history. Beyond that, enormous reserves of ice have been discovered just beneath the surface in certain locations, sitting close enough to the surface to function almost like a sealed time capsule. And there's another mystery layered on top of all this. Periodically, instruments detect small traces of methane in the Martian atmosphere. On Earth, a significant portion of that gas comes directly from biological processes. There are plausible a remarkably long stretch of Martian history. Beyond that, enormous reserves of ice have been discovered just beneath the surface in certain locations, sitting close enough to the surface to function almost like a sealed time capsule. And there's another mystery layered on top of all this. Periodically, instruments detect small traces of methane in the Martian atmosphere. On Earth, a significant portion of that gas comes directly from biological processes. There are plausible once, so far, no definitive proof has ever been found, but discovery after discovery keeps that possibility stubbornly alive. The Perseverance rover, for instance, is currently exploring Jezero Crater, a region that scientists believe held an ancient lake billions of years ago. The rock samples collected there preserve a record of an environment that may have remained habitable for a remarkably long stretch of Martian history. Beyond that, enormous reserves of ice have been discovered just beneath the surface in certain locations, sitting close enough to the surface to function almost like a sealed time capsule. And there's another mystery layered on top of all this. Periodically, instruments detect small traces of methane in the Martian atmosphere. On Earth, a significant portion of that gas comes directly from biological processes. There are plausible Beyond that, enormous reserves of ice have been discovered just beneath the surface in certain locations, sitting close enough to the surface to function almost like a sealed time capsule. And there's another mystery layered on top of all this. Periodically, instruments detect small traces of methane in the Martian atmosphere. On Earth, a significant portion of that gas comes directly from biological processes. There are plausible a region that scientists believe held an ancient lake billions of years ago. The rock samples collected there preserve a record of an environment that may have remained habitable for a remarkably long stretch of Martian history. Beyond that, enormous reserves of ice have been discovered just beneath the surface in certain locations, sitting close enough to the surface to function almost like a sealed time capsule. And there's another mystery layered on top of all this. Periodically, instruments detect small traces of methane in the Martian atmosphere. On Earth, a significant portion of that gas comes directly from biological processes. There are plausible alive. The Perseverance rover, for instance, is currently exploring Jezero Crater, a region that scientists believe held an ancient lake billions of years ago. The rock samples collected there preserve a record of an environment that may have remained habitable for a remarkably long stretch of Martian history. Beyond that, discovery keeps that possibility stubbornly alive. The Perseverance rover, for instance, is currently exploring Jezero Crater, a region that scientists believe held an ancient lake billions of years ago. The rock samples collected there preserve a record of an environment that may have remained habitable for a remarkably long stretch of Martian history. Beyond that, and it rises more than 20 kilometers into the sky. If you transplanted it onto Earth, its peak would punch through the majority of our atmosphere. But Olympus Mons isn't alone. Nearby sits another colossal scar, Valles Marineris, a canyon system so immense it makes the Grand Canyon look like a crack in a sidewalk. This single gash in the planet's surface stretches roughly 4,000 kilometers and plunges more than 7 kilometers deep in places. Transplant something that size onto Earth, and it would cut clean across entire continents. Structures like these tell you Mars was once a far more geologically active world, a planet shaped by colossal internal forces over millions of years. And not all of that violence belongs strictly to the past. Even today, Mars is the stage for genuinely dramatic phenomena, including the famous Martian dust devils, towering columns of dust that can stretch several kilometers into the sky as they sweep across the plains. Seen from a distance, they look almost harmless, but they're proof that the Martian atmosphere is still very much alive and moving. And occasionally, that movement escalates into something far more dangerous, because dust storms on Mars don't always stay small. Small reddish clouds can grow into expanding systems that eventually engulf entire regions of the planet, and in extreme cases, they go fully global, wrapping nearly the entire surface in a haze that can persist for weeks, sometimes months. During these events, the sky darkens, sunlight plunges dramatically, and fine Martian dust infiltrates absolutely everything in its path. For any future human mission, this represents an enormous operational threat, equipment failures, solar panels losing efficiency right when power is needed most, visibility collapsing to almost nothing. But maybe the most fascinating part of all this isn't the danger itself, it's what these gigantic landscapes are quietly telling us, because every volcano, every canyon, every storm system points to the exact same conclusion. Mars was not always like this. Somewhere in its history, something changed. Something took an active, dynamic world and slowly turned it into the frozen desert we see today. And that mystery leads straight into one of the most tantalizing questions in all of space exploration. Was Mars once actually habitable? Orbiters and rovers sent to the red planet have uncovered ancient riverbeds, deltas, valleys clearly carved by flowing water, and minerals that could only have formed in the presence of large quantities of liquid water. Some regions strongly suggest Mars once had lakes. Others point to the possibility of entire oceans covering vast stretches of the planet's surface. In other words, ancient Mars may have looked far more like Earth than anyone ever expected. And that single possibility changes everything, because wherever liquid water exists, the possibility of life exists right alongside it. That's exactly why missions like Spirit, Opportunity, Curiosity, and Perseverance have spent years combing the Martian surface, not hunting for animals or plants or some lost alien civilization, but for something far more modest and far more profound. Evidence that microscopic life could have existed there once. So far, no definitive proof has ever been found. But discovery after discovery keeps that possibility stubbornly alive. The Perseverance rover, for instance, is currently exploring Jezero Crater, a region that scientists believe held an ancient lake billions of years ago. The rock samples collected there preserve a record of an environment that may have remained habitable for a remarkably long stretch of Martian history. Beyond that, enormous reserves of ice have been discovered just beneath the surface in certain locations, sitting close enough to the surface to function almost like a sealed time capsule. And there's another mystery layered on top of all this. Periodically, instruments detect small traces of methane in the Martian atmosphere. On Earth, a significant portion of that gas comes directly from biological processes. There are plausible geological explanations on Mars too, but its true origin remains genuinely, actively debated to this day. Maybe life on Mars never existed at all. Maybe it emerged and vanished billions of years ago, lost along with the water that once sustained it. Or maybe small pockets of life are still down there right now, hidden underground, sheltered from the radiation and the extremes raging across the surface above. The honest truth is, we simply don't know yet. And maybe that's exactly what makes Mars so endlessly compelling, because behind its hostile, hauntingly beautiful exterior, it's still guarding one of the biggest unanswered questions in modern science. After everything we've covered, one thing becomes impossible to ignore. Mars is so much more than just another distant world circling the sun. It is a planet of total extremes, nearly airless, dominated by a relentless cold, capable of swallowing itself in planet-wide dust storms, bathed daily in radiation with no natural shield to stop it. A place where survival demands technology, planning, and resources far beyond anything humanity has ever deployed off the surface of Earth. But maybe the most genuinely unsettling thing about Mars isn't its present at all, it's its past, because everything we've found points to one undeniable conclusion. This world was not always like this, and that's precisely why scientists remain so fixated on it, because studying Mars isn't just about understanding another planet. It's about understanding how habitable worlds can change, how environments that once seemed stable can collapse entirely, and maybe, uncomfortably, about understanding Earth's own future a little more clearly. At the same time, Mars remains humanity's single most likely destination for expansion beyond our home planet, a place where permanent bases might one day rise, where new frontiers might genuinely open up, one more step toward the stars. But if that day comes, the first colonists won't be arriving at a new home. They'll be arriving at a hostile, unforgiving, deeply dangerous world, a planet that challenges life in almost every conceivable way. And maybe that contradiction is exactly why Mars fascinates us as much as it does, because it represents two things at once. A quiet warning about just how fragile habitable worlds really are, and simultaneously, one of the greatest adventures humanity may ever undertake.